try this out, and we'll see if it works, and hopefully it's a lot better sound quality. So anyway, just finishing up what we didn't get a chance to talk about yesterday, and that is using tangent ratio to solve for an unknown side. And basically, again, what this comes down to is setting up tangent ratio. If I look at this, my angle that we're given here is 74 degrees. And what some people have taken to do to help them identify which angle they're working with is they draw a little stick figure up here to say, okay, that's my point of view. Because we talked about the right-left. It's dependent on, the side names are dependent on point of view for opposite and adjacent. Hypotenuse is fixed. Okay? Which side is the opposite for angle 74? X, and the adjacent is? Okay, and the hypotenuse we don't have any information on. So the tangent, when we take tangent, it's always tangent of an angle. In this case, we know the measure of the angle, so I put the angle's measure in there. Tangent of 74 equals the ratio of opposite over hypotenuse. That's how we set these things up. We always set up tangent 74 as equal to a ratio, or we'll do sine and cosine. It'll work the same way today. Okay? But the function of the angle is a ratio. Now, the other thing that this value is, tan 74, you have to remember, is a value into itself. I can't multiply, divide, add, or subtract from that 74. No matter what I do to both sides of the equation, tan 74 is a value. If you're wondering what that value is, you could punch it into your calculator and get the decimal value. You could look it up in the table in the back of your book and get the decimal value. But it has a value unto itself. Now, I have an equation to solve, however. My x is in the numerator. I'm dividing x by 24. How do I undo division? Multiply both sides by 24. Now, it's 24 times tan 74. I can't take the 24 times the 74. It's 24 times the value of tan 74. And here's where your calculator is awesome. I mean, your calculator knows what the tangent of 74 is. So you can literally put in 24 tangent of 74, close the parentheses, equals, and it'll tell you that that side is 83.7. So you set up your entire equation and do that. And you had to do some of that in homework last night. So that may have been a little difficult for some of you to get done because we didn't really get a chance to go over it so much in class. So if you didn't get that part of the homework done, you can get it done over the weekend here. Bring it to me on Monday. I'll still give you full points. All right? So I'm giving you that option this one time because we didn't quite get through the entire lesson. You can still turn that in on Monday, and I'll still give you the full points for the homework if you didn't get it completed. Okay? Fair enough? The stuff from last night. Some people didn't know the homework, not the vocab. I didn't say the vocab. All right? Now, sometimes it's a little different, and I did accidentally, I wanted the same triangle. Okay? We're just going to get rid of all this. So, we can set this one up. This is the same basic idea, but notice what I'm going to do is I'm going to take the 74 out this time. I'm going to use the other angle, which would be 16. How do I know that angle is 16? Because 74 and 16 together add up to 90 plus 90 is 180, right? So finding that third angle is pretty easy. Let's do 16 this time. Again, my angle's right here, so my point of view is right there. 24 is which side? The opposite, and x is the, okay, and tangent is opposite adjacent. So tangent of the angle is opposite over adjacent. There's my equation. I have to solve that equation. However, I have a little bit of a difficulty this time, and that is the x is in the denominator. That's a little bit messier. But I'm going to give you an easy shortcut for handling this. When the x is in the denominator of the fraction like this, technically, here's the algebra we're going through. I have tangent of 16 equals 24x, equals 24 over x. Technically, the algebra I'm doing is this. I'm multiplying both sides by x, cancels the x's here, and I have x times tangent of 16. Remember, tangent of 16 is its own value, equals 24, and then I could divide both sides by the tangent of 16. So x equals 24 over tangent 16. Essentially, what happened in that algebra process, the end result of it and the shortcut is we swapped these two values. We just swapped them. If the x is in the denominator, I can bring the x over here and the tan 16 down there. Remembering that the tan 16 is a unit. We never break up that tangent and that 16. I wouldn't just divide or subtract or do anything with the 16. It's tan 16 has a value. It has a decimal value that we're interested in. So the upshot of all the algebraic manipulation is a swap. So whenever I get that x in the denominator, I can just very easily swap that. And while that looks complicated, it's really not. It's just instead of hitting the times button, we hit the divide button on our calculator, don't we? So now I'm going to do 24 divided by tangent of 16. And it still comes up at 83.7, doesn't it? Which you already knew it was 83.7 from the last problem. So those are basically the two ways that my trig functions can set up. Either my x is going to wind up in the numerator or the denominator. If it winds up in the numerator, I multiply through by the denominator and we're done. If the x is in the denominator, we swap. Those are two different techniques you're probably going to have to use to solve most trig equations. Solving is usually not the issue. The issue is setting up. And some people get very kind of confused with what's going on, but just remember it's always the tangent of whatever angle is our perspective. Or as we're going to learn today, the sine or the cosine of that angle. All right? So that's kind of what we missed out on yesterday. Let's go to today's notebook. So here's just a couple quick warm-up type problems. What would the tangent of A be? What would the ratio be? Now again, some of you are already diving right into it and you're set to go, but for those who are a little confused, remember, this is A. That's where we're standing down here. Tangent of A would be what? 35 is the opposite over the adjacent, which would be 12. Okay? Find the perimeter of the triangle to the nearest tenth. Well, actually, let's not find the whole perimeter. Well, we could do it. We could do it. We could find the perimeter of this triangle. We've got the skills to do that. So, first I have to find this opposite side over here. If I know two sides, you can use Pythagorean theorem to find the third, right? So, there's the angle. That's where we're standing. X is which side? And 29 is the adjacent. So my formula would be tangent of the angle is opposite over adjacent. How am I going to solve that equation? Multiply both sides by 29. Now remember, very important, it's not tangent of 44 times 29. It's 29 times tangent of 44. If you put that in your computer, what do you get for in your calculator? What do you get for x? Everybody do this to make sure you know how to use your calculator here. Get your calculator out. You should get about 28.0049747. If you're not getting that number, this is one way I can check to see if you're in the correct mode or if you're doing it correctly. So I want to make sure everyone's calculator is working the way it's supposed to. You should get about 28.005. Yours is not. Okay. I can fix that. You're in the wrong mode. You're in what's called radian mode. Okay. I'm going to switch over to degree mode, and that should stay there then. And actually, if it equals, there we go. Well, you had divided by instead of times, didn't you?
Oh,
You got it? Okay. 44. Mode. You switch mode. Yeah, you want to be in degree mode. So bring that down, enter, and now second quit. There you go. Yep. Check. Yours not? Okay. Let's switch the mode on your calculator. Yeah, you're in what's called radian mode, which is a different way of measuring angles instead of degrees, which is using pre-calculator. So now you're all set. Yours? Mode, degree, enter, quit. Now I'll try it. No, because again, you can't put the 44 times 29 together. It's 44 has to go in front. I'm sorry, no, 29 has to go in front. 29 times tangent of 44. You can't multiply or divide the angle. Everyone else okay? No? Who said no? Okay. Malin, you need to stay in your seats. 28. Okay. Now, once I have this, now this side to the nearest tenth is 28, okay? Once I have that, I could then use Pythagorean theorem to find the third side, right? And then I could find the perimeter of that triangle. We aren't going to worry about that just yet. But, I mean, I could easily go 29 squared plus 28 squared equals c squared. And that's something that you should be pretty familiar with. 29 squared plus 28 squared is a big number, 1625, and the square root of that that third side is about 4.3 to the nearest tenth. So then the perimeter, we just add the 3 together. So there we are. We can actually solve some more complicated problems now with this. Today, all we're doing is pretty much the same thing, but we're adding 2 new ratios. So now we're getting our full arsenal of trig functions that we're going to have at this level. There are actually 6 trig functions, and if you count inverses, there are a lot more. But these are the 3 we're going to work with primarily when we're working in geometry. You want the others, again, pre-calculus, trig class, that sort of thing. The other 2 are called the sine and the cosine ratios. They are not sin and cos. And no, we aren't going to be like my student years ago who got his calculator out and just started pressing the sine button. And it says sin, and it says, look, I'm sinning. I'm sinning. That was the big joke, yeah. Okay. No. Okay. It's sine and cosine. We just abbreviate them S-I-N and C-O-S. Those abbreviations. But it's sine, S-I-N-E, and cosine, C-O-S-I-N-E. Okay. Just like tangent was opposite over adjacent, sine and cosine also have ratios associated with them. The sine ratio is opposite over hypotenuse. The cosine is adjacent over hypotenuse. So tangent only involves opposite and adjacent. Sine and cosine involve opposite or adjacent and hypotenuse. So it gives us a little bit more power. So if I look at this, anyway, something mark it down somewhere, there it is. I have 3 angles here. I have x, y, and z. Again, we're only going to use the acute angles. If I look at angle x, if that's my perspective, which side is the opposite according to angle x? The 12 would be the opposite. The adjacent would be the 5. And the hypotenuse is the, okay, for that one. So sine of x, the sine ratio would be opposite over hypotenuse, 12 over 13. Cosine would be adjacent over hypotenuse, or 5 over 13. And the tangent is opposite over adjacent. We learned that yesterday would be 12 over 5. What if we switch to angle y? Now which side is the opposite? Okay. Now which side is the adjacent? And now which side is hypotenuse? Same hypotenuse. Okay, so opposite and adjacent switched because we switched our perspective, but the hypotenuse did not. So now the sine of y would be what ratio? Sine is opposite over hypotenuse, 5 over 13. And the cosine of y would be 12 over 13. And the tangent of y would be 5 over 12. So not too tough to set up these different ratios. But we have to know sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. That's going to be really important to memorize. I mean, very, very, very important to memorize. So, how is that going to happen? We'll get that in a second. Let's try one particular problem here. This is going to be very typical. We have to figure out which function to use. Do I want sine, cosine, or tangent? I have to choose. You've always got now the 3 tools to use. You got to pick one with the one that's going to work. So what we do is this. The way we work at it, I say, okay, here's the angle I'm working with, 34. That's my perspective. Which side am I trying to figure out according to that? X is the opposite. 9 is the hypotenuse. Okay, because that's my right angle down there. AB would be the adjacent. We don't know anything about that, so it's not going to help me anymore. So, opposite hypotenuse. Which ratio, which function works with opposite hypotenuse? Sine. So now we can set up our equation. Sine of 34 equals, because 34 is the angle, opposite over hypotenuse. It's just like the tangent equation we did earlier, except instead of using the tangent function, we're using the sine function. Different tool, but it can use the same way. And it's kind of like having a Phillips screwdriver, a slotted screwdriver, and a Torx screwdriver, for those who know what that is. Okay? There are 3 different screwdrivers. They all work pretty much the same way, but they have different types of tips on them that will work on different types of screws and bolts. You can't exchange one for the other. But they all work pretty much the same way. Same deal is going on here. They all work pretty much the same way, but each one is different and has its own unique use. How would I solve that equation? Would I divide by 9 or multiply by 9 to eliminate that? And the 9 doesn't multiply with 34. The 9 multiplies the whole thing, sine 34. What do I get for a length? 5 point what? 032. So 5.03. We'll just take it to a couple decimal places. Okay? So we solved that problem. Do you have other options if you didn't like this option? If something wasn't working for you here, what other choice would you have? Well, if I know this angle is 34, I know this angle must be 56, right? So I could have used this angle instead, but then I wouldn't use sine anymore. I would use cosine because this side now becomes the adjacent for that angle. So adjacent hypotenuse, I'd use a cosine function instead of the sine function. We'll get the same answer. What is the potential downfall of switching angles like that? We're given this angle as 34, aren't we? So I'm really confident of that number. What if I made a mistake and did 66 instead of 56? I had to do 100 instead of 90. Then everything would be off, wouldn't it? So usually we'll work with the angle that we're given. We'll stick with that, unless it's necessary to make a change. But are there other options? Oh, sure. I can switch angles. What I can't ever do is use 90 as my angle. Okay, we're never going to use 90 as our angle because that's a topic for pre-calculus. It can be done. We can work with it. It gets messy. You don't want to get into that. So how do we remember this? How do we remember these ratios? And there's a phrase that is being taught, I don't know how long, since I was a student and before, so that's basically back in the Stone Age. But our little phrase goes like this, SOHCAHTOA. And if you ask anybody in any math beyond geometry about SOHCAHTOA, they will remember. They might not remember what it means, but they'll remember SOHCAHTOA. It stands for sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse. Ka. Tangent, oops, I thought I switched to blue. Tangent is opposite over adjacent. Toa. That's what that phrase stands for. Sometimes I see people write it this way. So you see the ratios right there as well. But SOHCAHTOA, it's not SOHCAHTOA or anything. SOHCAHTOA. It's kind of like what happens if you stub a toa. You soak a toa and it feels better, right? Okay, dumb, but there's all sorts of dumb ways that people remember this one. Okay, toa, T-O-A, so you get both letters in there. It's a way of remembering these ratios, you know which one to use then. And it is extremely common to see this phrase written on top of quizzes for the next few weeks, quizzes and tests. People get their tests, they write SOHCAHTOA on the top to remind themselves of this. It helps us keep straight. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite adjacent. So how do we choose what method to use when we're solving a triangle? Because now we can solve triangles using trig. We can solve using special right triangles. We can solve using Pythagorean theorem. There's all sorts of different ways. And this is kind of a decision-making tree we can work our way through when we're presented with a triangle and said, hey, figure out the sides of this triangle. And the problem is, it says find the unknown length or find the unknown lengths. And they give us a triangle. We kind of work through this tree. First thing I look at is this one of my special triangles? If it's 30, 60, 90, or 45, 45, 90, I should go with that. Because even though a lot of you have not found that the simplest way, it really in the long run is the simplest way to solve a triangle because it's a known pattern. And that's a great way to solve it. If that doesn't work, then we go next to try Pythagorean theorem. If I know two sides of a right triangle, I can find the third side using Pythagorean theorem. I don't need trig. I don't need to set up sine, cosine, or tangent, or anything like that. I can just use Pythagorean theorem to find the third side and be very precise about it. If I can't do that, the next question we have is, do we have the similar right triangles thing? Do we have the altitude of the hypotenuse? If we have that, that's our third choice. Finally, our last choice is trig. Now, one of the reasons trig is our last choice is because we have to estimate with trig. We aren't going to get nice exact answers like we are with those other ones. Pythagorean theorem will give me a third side we can be as precise as we want to be with the radical. But trig estimates. It's a great way to solve a triangle. It's not quite as accurate. So that's kind of our hierarchy of decision making when we're solve this triangle. First thing we took for special triangles, then Pythagorean theorem, then something else. Finally, if we can't do any of those other things, trig becomes our choice of how to solve the triangle. How do we decide which trig function to use? Okay, start by analyzing the triangle. Which angle am I working with? Draw your little stick figure once you decide. And I do recommend doing that, drawing your little stick person so you know exactly where your point of view is, so you know exactly what's opposite, what's adjacent, what's hypotenuse. It helps focus you in on the triangle. And that means you may have to copy a picture of the triangle into your notebook. It's okay. Then what sides are known? Once we've identified the sides, which ones do we know? Which one do I want to solve for? Which ratio, which function fits that situation? And then set up the equation itself. Do not try to do these without this very important part. Set up the equation. I always want to see something like tangent of 16 equals x over 5 before you give me a solution. I want to know which function you use, how you set up your ratio. If tangent was the right one to use in that situation. Even better if you can actually show me how you solved it. That way, if you put something wrong in your calculator, you can still get full credit, or almost full credit, because you've shown your work. So let's try to figure this out. These problems actually have multiple variables. When we're given a triangle with more than one variable, we just choose one at a time. This is like the setup for trying to solve things. It's like, eek, that can be tough. That one choice is to solve one at a time. The other choice is to use what I call the shotgun approach. It means those of you who do hunting and stuff like that know that a shotgun shoots out a whole bunch of pellets instead of just one bullet, right? Yeah? Well, it should, unless you're hunting the slugs. Okay? So you kind of do a whole bunch, it's a whole bunch of targets at once. If you target, you get a whole bunch of holes. Well, shotgun approach means we're going to set up a whole bunch of equations and just pick the ones that work. The more targeted approach is more like the rifle approach, where we pick one very carefully at a time. So here, let's go ahead and start with x. So let's move y aside for the minute. We won't even worry about y. So we start by picking, is this a special right triangle? A 36, 90, 45, 45, 90? No. Do I have enough information to use Pythagorean theorem? No, I just know one side. Is there anything else I can do with this? Not really. We got to use trig. The angle that's given down here is 80 degrees. So that's where we're going to be. Work with our given angle. Which side do I know? 6 is the opposite. X is the hypotenuse. So this has to be the adjacent down here, by the way. Which function uses opposite hypotenuse? Sine. So sine of 80 is opposite over hypotenuse. Oh dear, my x is in the denominator. What am I going to do? Switch. When x is in the denominator, we switch. So x is 6 divided by sine 80. And what do we get for that? 6.1. Okay. Sounds about right. Has to be longer than 6. It's the hypotenuse. Okay, now that we've done that, we can target y. Y is the adjacent, and we know the opposite. Which function uses opposite adjacent? Don't use the hypotenuse here, okay? That we just figured out. If you use that hypotenuse, that's an approximation. Now you're approximating off an approximation. You're losing accuracy. You learned that in science class, right? So use the one that you're given. According to my angle, this is the opposite. That's the adjacent. Which function uses opposite adjacent? Tangent. So my second equation would be tangent of 80 equals 6 over y. Again, variable's denominator, but we just swap that. And what do we get? 6 divided by tan 80? What is it? 1.1. Okay. There we go. We've solved that triangle. We found all three sides. That's kind of the targeted approach. The shotgun approach is more like this. All right, here's my angle. I'm just going to set up all three functions for that angle and then see which ones help me out. So I'm going to set sine of 57, cosine of 57, tangent of 57. And I'm just going to put the numbers in there. So 57, there's my angle. This side is the opposite. The adjacent, don't pick up yet. Spells it wrong. And the hypotenuse. Sine of 57 is the opposite over the hypotenuse, a over 11. I can solve that one. That'll be a good one for me. Cosine of 57 is the opposite, is adjacent over hypotenuse, b over 11. Tangent 57 is the opposite over the adjacent, a over b. So I did waste a little time. This one, because it has two variables, isn't going to help me. But these two I can solve rather easily. So I can use a more targeted approach, one at a time. I can use a shotgun approach where I just do all three equations and see which ones give me something I can solve. I don't care which choice you make. You're doing the same equations either way. Just some people find it easier to think one way versus the other. How about this one? Are we going to use trig here? Is this go through our decision tree? Is this a special triangle? Yes, it is. Right angle. So if this is 10, 20, and 10 root 3. All right. Your assignment is online. You'll have to download it if you haven't had it yet. Don't walk out of here and say, well, you didn't put it on the board. If you're walking out, that means you're telling me you're going to look it up yourself. Four 77, 3 through 15, 18 through 21. Yes. Right there.
I did every single class until this one. I practiced my homework so I could retake, so I could retake it today.
Good.